Inverse of secant function. Does the inverse of secant function exist? Let us first find out with the help of the secant function. First, look at the values of the secant function from some standard angles. You can pause the video to read the table properly. From this table, we can say that the secant function is not defined for odd multiples of pi by 2. So, the graph of the secant function looks like this. In the graph, we can see there are no curve for minus pi by 2, pi by 2 and 3 pi by 2 because secant function is not defined by odd multiples of pi by 2. Now let us check whether the secant function is invertible or not. We know that if a function is a bijection, which means that it is both 1, 1 and onto, then the function is invertible. First, let us check whether the secant function is an onto function. Since sec x equals to 1 upon cos x, so it is assumed all real values except minus 1 less than sec x less than 1. Therefore, the range of the secant function is all real numbers except open interval minus 1, 1. So, if we consider any point on the y-axis within this range, we can clearly see that there is a corresponding point on the x-axis. So, the secant function is definitely an onto function. Now, let us check whether the secant function is a 1, 1 function. For this, we will use the horizontal line test. Draw a horizontal line passing through the curve of the secant function. As we can see, the horizontal line intersects the curve at more than one point. This means that for each value on the y-axis, there are more than one corresponding values on the x-axis. So, a secant function cannot be 1, 1 function. And since the secant function is not a bijection, so it is not naturally invertible. So, how come we are studying the inverse of secant function when secant function is not naturally invertible? Confused? Don't be. There is a method by which we can make secant function invertible, and that is what we are going to discuss now. As of now, we know that the secant function is not naturally invertible because it is not a 1, 1 function. So, we can make it invertible by making it 1, 1 function by restricting its domain. Let's understand how we can do this. As we can see that the domain of the secant function is real number except odd multiples of pi by 2, and we know that the secant function is not 1, 1 function in this domain. If you look at the graph carefully, you will notice that the curve is repeating itself at a distance of fixed intervals. So, if we consider half curve from two cycles, for instance in the interval 0 to pi, we can see that in this interval the curve of the secant function passes the horizontal line test. This means that the secant function is 1, 1 within this interval, and we have earlier seen that secant function is always onto. This means that secant function is invertible in this restricted domain. Or, in other words, we can say that the inverse of secant function exists within the restricted domain. But if you notice, secant function is defined at x equals to pi by 2, so we must exclude pi by 2 from the restricted domain. Actually, the secant function is invertible in any of these intervals. So, the inverse of the secant function exists in each of these intervals. The inverse of the secant function is denoted like this, or it can also be denoted like this. We can read it as arc secant. This means that if y equals to sec x, then x equals to sec inverse y. If we look at the graph of secant function, we can see that the range of the secant function is all real numbers except open interval minus 1, 1. So, the domain of the secant inverse function will be all real numbers except open interval minus 1, 1. And the range of the secant inverse function will be each of these intervals because secant function is invertible in each of these intervals. Corresponding to each of these intervals, we get a branch of the function, and out of these branches, the closed interval 0 to pi minus pi by 2 is known as the principal value branch. Therefore, the range of the secant inverse function is closed interval 0 to pi minus pi by 2. And this is how we write secant inverse function. Thus, the inverse of the secant function is defined as sec inverse y equals to x if and only if sec x equals to y, where x belongs to 0 to pi minus pi by 2 and y belongs to r minus 1, 1. Let us now try to draw the graph of the secant inverse function. As we know that if y equals to sec x, then x equals to sec inverse y. So, the graph of the secant inverse function can be obtained by interchanging x and y axis of the graph of the secant function. This is the graph of y equals to sec x. By just interchanging the axis, we can draw the graph of y equals to sec inverse x. This shaded portion of curve from 0 to pi except pi by 2 is known as the principal value branch. Any value of sec inverse x within this interval is known as principal value of the secant inverse function.